Okay. Good. So here we have an example, okay? Over here, you might see this. I know in the textbook they do this. Sometimes you might see next to a rational expression, you might see something like this. X is not equal to a number A. Basically, they're doing that because that number A is not in the domain. And they're essentially saying we're assuming that we're working over the domain. I mean, that's not going to be an issue in this class, but it is something that the textbook does. I'm not sure if other sources do that, but now you know what it means, though, if they do. Again, they're just basically saying we're working in the domain of this. So here for this example, we're assuming x is not -2, right? And you can see if it was, we'd be divided by 0. All right. So we want to know if this thing is, we want to simplify this. Excuse me. We want to simplify this, okay? Well, notice it's easier. The denominator is already factored. Now, the numerator is not that hard to factor, so let's just factor it, right? I mean, here you can see that the smallest power of x is x squared, right? So just like when we factored out GCFs, we can factor out x squared. When you factor it out, what do? You divide to see what's left over, right? That's what we're doing here. And when you do that, you get x squared times x cubed over x squared plus 2x squared over x squared. And so that's going to be x squared times x plus 2. So here we just factored immediately. And what we get is this. And you can see that x plus 2 is a common factor, so we cancel it, like so. And we're left with x squared. Good. That's good. Okay, so we have this. All right, so that's one example. Are there any questions about this example? Here's another one. So here we can factor the top and bottom in this case. So we have x squared plus 2x minus 3, right? To factor that, we need two numbers, right, whose product is -3 and the sum is 2. Well, 3 and -1 do that, right? 3 times -1 is -3. 3 plus -1, or 3 minus 1, that is 2. So the top here is equal to x plus 3 times x minus 1. Down here, x squared plus x minus 2, right? Here we have we want two numbers whose product is -2. The sum is 1, right? What about -2 and 1, right? The product is -2. If you do 2 and -1. If I said -2 and 1, I'm sorry, my mistake. 2 and -1. The product is -2. 2 plus -1, which is 2 minus 1, that's a 1. So we have this equals this, right? So the top is x plus 3 times x minus 1. The bottom is x plus 2 times x minus 1. And of course, you can see that there's some canceling, x minus 1s. Now it's simplified, okay? So this has been simplified down to this. Notice that we're implicitly assuming that x is such that the denominator is not 0. Well, that's what we're assuming. So x is not -2 and x is not 1. We're assuming that. Okay, and again, that's because the denominator cannot be 0. So just something to point out. Okay, so we have that example. Here's another one. Let's simplify this one. Now, we could factor the numerator and denominator. As you'll see though, okay, we can use the factor theorem to help us. We'll do that on the next slide. For the numerator, that's pretty easy to factor, right? I mean, basically you can factor out x squared, right? X squared is the smallest power of x. So we get x squared times x cubed minus 4x squared over x squared, right? Right? You have to divide to see what's left over. And so when you divide into each term, like so, and you get x minus 4. Excuse me, x squared times x minus 4. Okay, now for the denominator, I mean, you can see that we could factor out x squared, okay? I mean, that's pretty easy to see that you can factor that out. X squared is the smallest power of x. So we put x squared in front, and we have to divide to see what's left over. So we get this, like so. So 3x to the fourth over x squared, 11x cubed over x squared, 4x squared over x squared. Right? Again, we put x squared in front because we're factoring it out. X squared is the smallest power of x. So we divide to see what's left over. Divide to each term. And when you divide, right, you subtract exponents. So here becomes 3x squared. This here becomes 11x. This here becomes 4. So we have this. So yes, we did factor a bit. So when we go back, you know, we substitute. And of course, the x squares, let me mark it in, they cancel like so. And we have this. Okay, now we're not quite done because how do we know this whole thing is simplified? Well, you could factor the denominator, right? You know, you could use the AC method. But really, all we want to know is, do these have any common factors? And that really boils down to asking, is x minus 4 a factor of the denominator here? Well, notice that if we evaluate the denominator at 4, right? Plug it in. We end up getting 0. Right? And if you go back, let me go back to the factor theorem. Here it is. Remember, from the factor theorem, p is a polynomial, a is a number. X minus a is a factor of p of x exactly when p of that number a is 0. So by the factor theorem, right, x minus 4 is a factor of our polynomial. So x minus 4 is a factor of the denominator. Okay, so we're not done yet. Now we could factor it, but if we can also just divide. What's nice about this is, since you're dividing by x minus 4, we can use synthetic division. Right? So remember, we have the polynomial here. We have x minus 4, so 4 goes here. Right? You have one column for each coefficient. Here we have all the terms, so we don't have to put zeros as placeholders. And remember what happens next. Let me get that wonderful pen. Let me use a different color though. Remember what happens? The 3 is down here, like so. That's where the 3 comes. And now what happens next is you do 4 times 3, and the answer goes here. That's why the 12 is there. Next, you have a negative 11 plus 12. Wait, actually, let me get rid of that. Right? You add the 2, and that's why there's a 1 down there. And then you do this whole process on 1 now. So now you do 4 times 1. That's 4, which goes here. Negative 4 plus 4, you get 0. Okay, remember also, the quotient, these are the coefficients of the quotient. The last column here, this number is the remainder, and the quotient is 1 degree less than the dividend, which in this case is 3x squared minus 11x minus 4. So it's degree 1, and the coefficients are 3x and 1, 3 and 1. So we get x minus 4 times 3x plus 1. 3x plus 1, in other words, is the quotient. The remainder here is 0. So we get this. So now it's factored. Good, good. Okay, so that's good. And what's good about that also is once, right, we plug that in, the x minus 4's cancel, and we get 1 over 3x plus 1. So that's what we get here. Any questions on that? Okay, so again, we factored top and bottom. That's how we got the x squared out, okay? Right, we factored top and bottom. You know, we saw that x squared was a factor, so we did that immediately. Then we got this. The top is already factored completely, right? The bottom, you could try factoring, but it's enough to see if the top and bottom share factors. Using the factor theorem, we see x minus 4 is a factor, so we're not done. But how do we get the other factor? Well, we divide. That's where synthetic division came in. And again, this is x minus 4. That's why we had a 4 here. If somehow we did x plus 4, then we would have minus 4 here. I'm bringing that up because a few people have asked me about that, which is okay. So nothing wrong with that. Okay.